So I'm Alice. I'm a project manager at FAB Big Data SNCF.
So hello everybody, my name is Guido Intronati. I'm a data scientist also at the FAB Big Data at the SNCF.
So we have 15 minutes to answer the question, how a large corporation such as SNCF reinvent itself
You're going to be late?
through AI.
Good.
So we made our presentation around
I messed up.
one
I usually
use
push it right to
case
the last second.
to keep concrete. But
I've never been
first,
charged of the
let
time.
me introduce very quickly SNCF Group, which is indeed a large corporation. So basically, what do SNCF? Basically, we carry people, we carry merchandises, we ensure the maintenance of railway network, of rolling stock. We have also a very large real estate asset. We have the first French business website with voyagesncf.com. We also have an app SNCF, with 2 million users. So we have a very wide range of activities. And through these activities, we generate massive data, a large amount of data, a wide variety of types of data. And these data are our raw material to conduct use cases through AI, for sure. The idea is to address key strategic issue of SNCF. I mean, generation of value, I mean customer satisfactions, I mean security. So now let's turn to a very concrete use case to begin with, so which is a vegetation use case.
Yes, so I'll talk about a concrete example of a project that will be put into production soon. This project concerns the management of the vegetation alongside the railway. So please note that when I say vegetation, that term also includes animals. So to give you a little bit of a context of the impact vegetation has on the railway, just think about the falling leaves. When leaves fall, they stick with the damp rail. The passing train will compress them into a smooth, slippery layer that will reduce the train's grip. So that means that the train driver has to brake earlier when approaching station or signals in order to avoid overshooting, and he also has to accelerate more gently in order to avoid wheel spin. Other major risk factors can be animals wandering along the railway or falling trees, for example. The maintenance and the prevention measures are extremely costly. So choosing the areas that have to be treated with priority is a crucial issue, especially when you have 95,000 hectares to manage, as the SNCF has. To give you an idea, 95,000 hectares is 9 times the surface of Paris. So in this project, our goal is to provide the expert with a map showing the risk zones so that he can construct an effective maintenance plan. So the question is, how do we build this map? How do we proceed? Let's start with data. These data are the reports of the agents that they have to fill during their journey. There was an incident. So in this report, what we will find is, for example, the location indicated by the code CI, but it turns out that actually this location is given between 2 points, so it's not very precise. What we will do is to look into another field, namely the description field, where the train driver will also indicate a more precise location. There is, if you look, you see a PK. This is the location of the incident given in kilometers. So in this description field, the train driver will also, of course, describe the incident. And then lastly, we will also have the delay associated with the incident. Here, I would like to point out that the quality of this report is not very regular. Actually, it's very irregular, because sometimes the description doesn't contain much information, or it's just not complete. What do we do with this data? What we are looking for? So So in order to extract the valuable information from this description, we want to build a system that will look into this description text and tries to identify essentially two elements: the location, if it's provided, and the type of incident. Is it a fire? Is it an animal? Is it a slippery rail? Or is it a falling tree, for example? This classification, it will be made by searching for characteristic terms. So we end up with an incident, with a classified incident, the associated delay, and an improved location, just by looking at the text in this description field. We will then aggregate all this information in order to produce a map showing these risk areas, these risk zones, and to each zone we will assign a score according to the aggregated delay. So the idea is that the expert will use this map to monitor his zones, the high-risk zones. He will be able to optimize the maintenance programs, maintenance plans. I've been talking about historical data. Okay, so we are concerned with what happened in the past. In the next step of this project, we want to predict somehow the risk, just by integrating some external variables like maintenance works already performed, or some meteorological data. We want to be able to estimate, for example, the risk that an incident will occur in a given section of the line. We want to predict that, so we will build a prediction model. This leads me to the point about the complexity of the model that we can employ, because we want to make models that are understandable. We want to be able to explain how our model works, and if it makes an error, the reason for this. Otherwise, it will be very hard to make the expert trust our model, at least in the beginning of the project. And on the other hand, something that's very interesting is that we expect that the fact of using this report to produce something valuable will set a virtuous circle, because we will encourage the train drivers to make higher quality reports. The report that will be well written and with more details, because they will see how their reports are being used for something useful. And this will, in consequence, due to these higher quality reports, this will, in consequence, improve the output of our model. So we can see this as a step that will allow us to improve the quality of our data.
So through this example, I'd like to enhance at the end some of our key challenges and lessons learned till now, so SNCF can reinvent itself with AI. So first, we have to do with our traditional background and make it change gradually. What do I mean when I talk about traditional background? I want to talk about data and culture. First, concerning data, data are generated at SNCF through complex processes in a quite siloed organization. So data quality is relative, as Guido explained. But we can also improve data quality if end users understand the importance of data and what data can bring, how data can facilitate their work. Next, I'd like to talk about culture. SNCF has an engineer culture, a 100% culture. So it's important, and Guido said it, we have to be able to explain a model, but we also have to implement a probabilistic approach. I mean, we have to change paradigm. So I guess you perfectly understand that change management is absolutely mandatory at SNCF. Next, another important message is that we have to sequence our ambitions. We have to think big, but start small. Through vegetation use case, we become aware that we have to understand in a first project before trying to predict. So, yes, we have to think big and start small at the end. There is a lot of value at all these stages: the now, the understand, predict, and prescribe. And the more we conduct projects, the faster and deeper we will conduct new projects by capitalizing on technical assets, on methods, on data knowledge. And this capitalization is possible at SNCF through expertise centers, because we are organized around expertise centers as Fab Big Data. And at Fab Big Data, we come together, we bring together key resources, infrastructure, but also competencies. And we work closely with group entities, with end users, to define their needs. We work closely with local experts too. And obviously, we try to collaborate externally with academic entities and business entities like startups. So typically, we have a partnership with Cher Ivado, Polytechnique, et Montréal.
To sum up, and what is the message we want to convey? We are paving the way for an artificial intelligence at SNCF. We know we have many challenges that are in many aspects particular to a large and an historical company. But on the other hand, we know that this is a step-by-step process and that we have the resources to make it. Thank you for your attention.